Welcome to today's Bitwarden Brilliance. My name is Adam and I'm an integration engineer working at Bitwarden out of Italy. As part of my job role, I'm responsible for pre- and post-sales technical questions and support. Today I'm going to showcase a few Bitwarden features that we frequently get questions about and demonstrate a few workflows that will hopefully help current and prospective Bitwarden admins understand and implement best practice when working with Bitwarden organizations. In particular, in today's session, I'm firstly going to demonstrate a few workflows for onboarding users with SSO with trusted devices, before moving on to the concept of a server in Bitwarden and how that affects where your data is stored. Finally today, I'll look at ways that you can provide access to the Bitwarden CLI to your users as part of an organization using Trusted Device Decryption. Before diving in, I'd like to quickly introduce Bitwarden as a company. Bitwarden was founded in 2016 and has always been based on open source principles. This means that the full Bitwarden source code, for both the server and all clients and additional utilities, is available on GitHub. And alongside this public exposure, Bitwarden regularly completes comprehensive external security audits, the results of which are made available at bitwarden.com/compliance. A full breakdown of the Bitwarden security model is available in our white paper, alongside other resources available on the Help Center. There are plenty of other reasons to use Bitwarden, some of which are given in this slide, and one particular advantage that I'd like to highlight is that in addition to the SaaS offerings, Bitwarden is the world's leading enterprise-grade self-hostable password manager. To highlight just a couple of other aspects of Bitwarden that you may be less familiar with, Bitwarden also features an integrated secrets manager, available to eliminate the hard coding of secrets and to provide a centralized and audited storage for your programmatic secrets usage. I'd also like to showcase the Bitwarden Labs GitHub repo, which is distinct from the main Bitwarden repositories and features examples and demonstrations of how to use Bitwarden services and features. Today I'll be using a mixture of a cloud-hosted organization on bitwarden.com using infrastructure based in the USA, alongside some demonstration self-hosted infrastructure. Bitwarden also has a distinct EU-located server at vault.bitwarden.eu, which is cryptographically independent from the US-based one. Finally, many Bitwarden customers choose to self-host their own vaults on premises. Bitwarden offers full feature parity across all of these different environments. Let's get on with the first demonstration. In Bitwarden, logging in has always been performed in two steps: authentication and then decryption. This is different from many other services that you may have in your organization, where a simple username and password and maybe a 2FA stage is all that you need to obtain access. Bitwarden's zero-knowledge encryption actually goes even further and offers you many different combinations of ways to perform these authentication and decryption phases. The default method is to perform both authentication and decryption just using a master password, with an optional but highly recommended 2FA challenge being performed as part of the authentication stage by the Bitwarden server itself. In this case, the master password is serving as both an authentication challenge and as part of the vault decryption, although for convenience it only has to be entered by the user once. Many admins choose to use SSO to perform the authentication stage of the login, and in this configuration we'd recommend that the 2FA stage of the authentication challenge is also performed by the SSO IDP, allowing for excellent centralized control and flexibility. However, note that due to Bitwarden's zero-knowledge design, the SSO IDP cannot know the decryption secret for any user, so this will be provided by one of three methods currently offered by Bitwarden, namely Master Password Decryption, Trusted Device Decryption, or Key Connector. The method that we're going to look at in detail today is SSO with Trusted Device Decryption. I'll read from the help documentation for just a moment here, which explains that trusted devices allow users to decrypt their vaults using a device-stored encryption key, eliminating the need to enter a master password. Trusted devices must either have been registered in advance of the login attempt or can also be approved through one of a few different methods. SSO with trusted devices gives business end users a passwordless experience that is also zero-knowledge and end-to-end encrypted. This prevents users from getting locked out due to forgotten master passwords and allows them to enjoy a streamlined login experience. To start off, I'm going to demonstrate this trusted device flow from the point of view of two Bitwarden users. The first will be a demo owner account, adam@atjb.link, represented by this blue instance of the Firefox browser. I'll also be using a test user, tj@atjb.link, represented by this pink instance of Firefox. The tj@atjb.link user currently does not exist, so I'm going to start off by following a standard onboarding process, whereby I create an invitation for TJ to join my organization, setting his privileges and any collection access accordingly. It's worth noting that in the majority of cases, this step would be performed automatically, with access synced across from your IDP. However, for the sake of simplicity, I'm going to demonstrate this manually today. Once the email invitation arrives into the user's mailbox, I'll click the Join Organization button, whereupon I'll be taken through SSO authentication, which is happening in the foreground here. And as this is the first device registered for this user, this device will be automatically approved. This device now has trusted status. I can view this in the user menu, and I can log out and back in without having to enter any master password for a true passwordless experience. In the majority of cases, users will want to add a second Bitwarden client. Here I'm going to add what is probably the most popular client available, the browser extension. However, the process would also be the same were I to add the desktop application, the mobile application, or even another browser or a new browser profile. After the authentication steps, this time happening automatically in the background as a result of my previously set SSO cookie, I am prompted with the following menu, asking me to approve this new device, i.e. to provide this new Bitwarden client with a decryption key for my vault. As a user, I am presented with two options. The main option would be to approve this device myself, but I could also ask the admin to do this for me. Let's take a look at option 2 first, asking the admin to approve this new Bitwarden client for me. When I do so, a device approval request is sent to the organization admin panel, where anybody with access can view and either approve or deny the request. In addition to this, an email will be automatically sent alerting the Vault admins as to this pending request. It's worth noting the information that comes along with the request. In addition to general metadata such as the username, timestamp, device type, and IP address of the client creating the request, we have a unique fingerprint phrase. This fingerprint phrase can be used by the admin as a verification method to check that this device approval request is valid, for example by contacting the user directly or by having the user submit this fingerprint phrase to a secure web portal. It's also worth noting that this capability is available via the CLI tool, including the display of the fingerprint phrase. While we would always advise utmost caution when performing any automation of device approvals, a control based on this fingerprint phrase would be a recommended step for any organization looking to implement such an automation. For now, I'm going to deny this request and attempt to log in again using the browser extension for my user TJ. This time, I'm going to demonstrate that the user can actually approve his own devices without needing to get the admin involved. This flow is our recommendation. Not only does this flow avoid the need for admins to approve multiple trusted device approval requests, but additionally this allows for the user himself to confirm or deny incoming requests based on his knowledge of his own actions. That's to say, is there a request that he was expecting, in which case he can approve it, or not. For further clarification, I'd like to point out that our recommended end-user trusted device flow not only does not require the intervention of the organization admins, but is in fact an entirely separate process, hence why these requests are not even displayed in the admin panel. This allows for admins to focus on the few situations in which users have specifically requested admin assistance in regaining access to their vaults, perhaps in a situation where they genuinely have lost access to their trusted devices, thereby avoiding alerting fatigue and ensuring that these genuine requests are seen to promptly. I hope that this demonstration proved useful, and as always, feel free to get in touch with the Bitwarden support teams for any additional clarification on this or any other aspect of our services. I'd now like to look very quickly at the Bitwarden server-client architecture and take the opportunity to clarify how various objects such as users, items and organizations behave in relation to the server they are created on. Bitwarden uses a server-client architecture, meaning that a Bitwarden server will host the data that is accessed and written to by various and multiple Bitwarden clients. The first question to cover is therefore, why does Bitwarden work in this way? Why was this design choice made? Using a server-client architecture provides many advantages, of which the principal is perhaps that the server acts as a single source of truth. This means that when sharing your credentials amongst hundreds, thousands, or tens of thousands of different users, you can be sure that the credentials being accessed are correct, and you will not have issues with versioning or credentials getting out of sync. The server-client architecture also provides a convenient way to sync credentials amongst your devices. A credential created on, say, your mobile phone can be pushed to the server and used on any of your other devices within seconds, appearing along with all relevant metadata and logging in your browser extension on your desktop, for example, or even accessible for automation via the CLI. Finally, the central point of the server also allows for centralized administration, whereby configuration and policies can be set in a single place by organization admins and pushed out to govern the usage of Bitwarden by organization members. Let's now move beyond this architecture overview and take a look at the various clients available to Bitwarden users. Bitwarden offers multiple different clients, namely the browser extension, the desktop application, the mobile application, and the CLI tool. All of these clients must be downloaded to the Bitwarden user's device, whether that be a desktop, a laptop, or a mobile device, and then configured to log into a specific server, at which point credentials and authentication are requested from that user. It's worth noting that there is another client, the web app. This is when a user enters the domain of the Bitwarden server into a web browser, for example vault.bitwarden.com or vault.bitwarden.eu, at which point the vault can be accessed and modified in exactly the same way as through any other client. Even though nothing actually had to be downloaded by the user, e.g. from the App Store, the Play Store, or the browser extension marketplace, that downloading actually took place in the background when the browser visited the server's web page. There is therefore nothing special or different about accessing the vault or organization directly from the web app. It simply functions as another client. Moving over to the server now, Bitwarden is special in that not only are there two servers provided by the Bitwarden organization as SaaS solutions available at vault.bitwarden.com and vault.bitwarden.eu, but the server code is made available for end users to host themselves. I'm going to demonstrate that today with a couple of example Bitwarden servers, which I've hosted at pink.atjb.link and blue.atjb.link. There's nothing unique or different about the servers provided by Bitwarden at vault.bitwarden.com or EU compared to self-hosted servers. They run the same server software available to self-hosting admins, and the end-user experience is the same whether a user is connecting their clients to .com, .eu, or one of the tens of thousands of self-hosted Bitwarden servers being run by various organizations throughout the world. The important factor, though, is that while the services and features provided by each server are the same, the data and secrets stored on each server are unique to that server. What this means in practical terms is that if I create an account, organization, or secret on, say, vault.bitwarden.com, it will be available only on vault.bitwarden.com. It will not be replicated on vault.bitwarden.eu any more than it will be replicated on any of the tens of thousands of self-hosted Bitwarden servers available out there. To make this point a little clearer, I'm going to quickly show a couple of demonstrations using the System Admin Portal. This is a feature available to admins running self-hosted servers that gives a top-level overview of the users and organizations available on a Bitwarden server. It's worth mentioning that while the users and organizations present on the server are visible, Due to the Bitwarden zero-knowledge architecture, the decryption key for these secrets owned by these entities is not available to the admin, and therefore no secrets or data stored by the users can be decrypted or seen through the system admin portal. I'm using two browsers here, one for each instance of the Bitwarden server I'm going to demonstrate with. As my browsers are coloured pink and blue, I've simply called these servers blue.atjb.link and pink.atjb.link. I'll begin the demonstration by creating a new user, user1 at atjb.link, with the password password1234 on my first server, blue.atjb.link. It goes without saying that both the choice of password and the fact that I revealed the password in this video are both extremely poor security practices, and this is done for demonstration purposes only. Now that the user is created, I'm going to create a new item inside his vault. I'm simply going to call this item 1. I'll add a note to this item demonstrating that this item was created on the blue server. Now that this user has been created, we can examine him in the system admin portal. We can see that the user exists, and we can see that one item has indeed been created in his vault. Moving over to the pink server and trying to log in with the same username and password as before, we can see that this login attempt fails with an incorrect username or password error. If we have a look at the reason why this is, by moving over to the system admin portal, we can see that just as we expected, while the user has been created on the blue server, this user does not exist on the pink server, again demonstrating that items and users and organizations are not synchronized between Bitwarden servers. To give another demonstration, I'm going to create a user which happens to have the same username, user1 at atjb.link, on this pink server. I'm going to give it the same master password. I'm now able to log in on both pink and blue with user1 at atjb.link and the password password1234. However, when I do so on the pink vault, we can again see that no items exist in this user's account, and that even though both servers now have a user called user1, these user objects are different. We can also see this by the fact that the user ID for both of these users is different. Another way that we can prove that these are different users is the fingerprint phrase. The fingerprint phrase is the result of the cryptography used when creating a user account, and we can see that again, even though that these users have the same username, they have different fingerprint phrases. These users are not synchronized between the servers. Final point that I'd like to make here is shown by a demonstration of uploading an organization license to each server. So it's actually the same organization license, taken from the same cloud organization. The only difference is the installation ID is set accordingly for each server. Once again, when we create these organizations on both pink and blue, we can see that the organization name is the same for both of them, ATJB organization, but that the organization ID is different. This is available both in the top URL bar as demonstrated here, but also when viewing the organization objects in the system admin panel, we can again see that these organization IDs are different, even if everything else about the organizations is identical. By now it should be clear that configuring users' clients to connect to the correct server is an essential part of rolling out your Bitwarden deployment. While users are free to perform this step manually, in that you can simply inform them to connect to the correct server domain, either bitwarden.com, bitwarden.eu, or your self-hosted fully qualified domain name, our recommendation is that this step is configured centrally by Vault admins in order to speed up and simplify your users' onboarding experience and reduce the chances of user error. Bitwarden offers several methods of deploying the server URL to your users' Bitwarden clients, including via Intune and GPO policies. Please consult the documentation available on the help page and feel free to get in touch with the team for more information. I hope that this quick demonstration was useful in explaining the role and importance of the server when it comes to selecting your Bitwarden service, and would like to point out just one more time that while I demonstrated these concepts today on a pair of self-hosted servers, blue and pink.atjdb.link, the same concepts and principles apply equally to objects created at vault.bitwarden.com and vault.bitwarden.eu. As noted in part 1 of this session, Bitwarden CLI, or Command Line Interface, does not use Trusted Device Decryption to decrypt or encrypt Vault content, so Vault data must be decrypted using a master password. This allows for some interesting use cases, as users onboarded to an organization using Trusted Device Decryption will not ordinarily possess this, and therefore by default will be unable to unlock the Vault when using the CLI. It's important to note that Vault admins and owners will always possess a master password, while the primary result of these users having a master password in addition to their trusted devices is that this allows these powerful and privileged users to act as break glass accounts should the SSO integration go down for any reason. A secondary use case is that these users will be able to use the CLI without any additional steps being required. This is something that often aligns well with the needs of these users to run actions in bulk against the Vault, or to set up automations based on certain events taking place. However, in order to comply with the principle of least privilege, it would be a poor idea to simply set up all of your organization's potential CLI users as owners or admins. As such, we're going to explore a couple of other ways to supply your regularly privileged users with master passwords, thereby allowing them to use the CLI without escalating their privileges unnecessarily. The first way that we can do this is very simple, and that's to create the user account before onboarding them to the organization. When an individual Bitwarden account is created, the default workflow involves setting a master password, and this master password is not removed when onboarding into an organization using Trusted Device Encryption. As such, if the user that you wish to use the CLI does not already have a Bitwarden account and needs a master password to do so, then the simplest way forwards may well be to have that user create an individual account, which comes with a master password by default. In cases where the user is already enrolled into the organization and is therefore decrypting his Vault using trusted devices only, the Account Recovery Administration feature can be used to reset the decryption method of the user and add a new master password. Once this flow is complete, the user will be in possession of both a master password and a trusted devices chain, and will therefore be able to take advantage of both a slick, passwordless experience for his GUI clients, as well as a master password that can be used with the CLI. Let's have a look at what that looks like right now. I'll start off by deleting the user that I've just provisioned, and I'm going to be able to go through the onboarding process for that user again from scratch. Bear in mind that since they were using an account at a domain that is claimed by this organization, the action when offboarding this user is deletion, and therefore the tj@atjb.link user object has not merely been removed from this organization, but actually deleted entirely from the server. That's great, as it gives us a clean slate from which to start this demonstration again. I'm now going to use a type of onboarding called JIT, or just-in-time provisioning, whereby this user, despite not having an account available on the server, can use the login with SSO method, provide valid IDP credentials, and have his account provisioned on the server and automatically placed into an accepted state in the organization, as well as being given his first trusted device, this web browser. As we showed in the previous demonstration, we could now use this browser to extend the trusted device chain to additional trusted devices, but the focus of this particular demonstration is to obtain a master password for this user so that he can use the CLI. We're going to do that using the Account Recovery Administration flow from the point of view of the org owner, admin, or an appropriately privileged custom user. When I initiate this flow, I am prompted to set a new temporary password to serve as a decryption key. At this point, I have two options. If I'm performing a takeover of this account, then I could set that temporary secret to something that I know, or if I do intend for this user to continue using this account, such as in this case, I could share a temporary secret with the user. Bitwarden Send with a one-time link would be a great example of a way to do this. Moving back to the perspective of the user, I can see that I have received an email notification that my account has been taken over, and when I follow this, I am invited to set a new master password, which I can now use to access my account. As a small side note, although the purpose of this demonstration is to obtain a master password for use with the CLI, there's nothing stopping me from using this in other ways, here demonstrated by using the master password to approve a new trusted device, an option only presented to users for which it is available. Moving over to the CLI now. Even though there is no GUI for this client, it still functions like any other Bitwarden client, in that it is subject to the same restrictions and policies as if I were accessing the Bitwarden organization in any other way. Namely, that I need to authenticate using SSO for this organization. This is accomplished using the -SSO option, and once I authenticate, I can use the master password previously created in order to decrypt the vault. Finally, I may well wish to use the CLI for automation purposes, in which case the interactive login just demonstrated will not be suitable. I can achieve this by passing the API key argument and providing the user API key. It's important to note that this API key is different from the organizational API key, which is only available to org admins. This API key is available from the user's individual account menu, which is of course securely gated behind your SSO login flow. Once I have obtained this secret from the GUI, I can then use this to authenticate in the CLI client, and finally to pass the decryption secret as another argument, allowing me a fully automatable service user with exactly the privileges that I choose to give, even in an organization where all other non-privileged users are making use of Trusted Device Decryption only. I hope that this demonstration has proven both informative and enjoyable, and as always, would invite any follow-up questions to be submitted via the usual channels. Happy credentials management.